All right. Good afternoon, everyone. My name is Charles Nebeze, and I'm the Vice President, Business Development and Commercialization with the Center for Excellence in Mining Innovation, and also with the Mining Innovation Commercialization Accelerator. So today we're going to be doing our webinar number 9 of the approved MICA project. And today's presentation is going to be by H2 Nano, and they'll be talking to us today about passive sunlight treatment for managing mining process water risks. But before we jump into that presentation, I want to let you know that we do have 16 approved projects from the MICA's first call for proposals, and we have just recently opened our second call for proposals. It's going to be open from December the 1st to January the 13th of next year. So here's a listing of the projects that we're currently funding, just so you can see what those are right here. Here you can see these are the logos of the companies that we are going to be supporting. And this is the link for you to be able to access that second call for proposals. So if you've got a camera on you, take a picture of the screen, be able to go to this link that you see on the screen here with a QR code. Now, I'm going to hand over the conversation to Zach, who's going to be speaking to us about passive sunlight treatment for managing water risks. And Zach is with H2 Nano and is the Chief Operating Officer. Zach, take it away.
Super. Thanks, Charles. All right. Let me just bring up our presentation here. Great. Very appreciative of having the support of the MICA program for the development of our solar pass technology, which I'll be sharing with you today. H2 Nano is a environmental technology company focused on solutions for passive water and emissions treatment. We'll be talking to you today about our flagship technology, which is Solar Pass, and a platform for being able to bring high strength water treatment and emissions control to the field in a form factor that is low input and nature powered. So as I mentioned, Solar Pass is a passive sunlight activated technology. It performs two key functions for us. One of them is the delivery of advanced oxidation using solar energy. So we deploy the material into the field. It floats at the surface of the water, collects sunlight, and uses that energy to be able to generate treatment chemicals in place to treat contaminants in water or perform it for a few other functions that are relevant to the mining sector, which we'll talk about today. The idea here is being able to deliver the same high-strength chemical oxidation that would be from conventional chemical treatment processes, but in a form factor that is more passive, lower input, doesn't require grid-scale electricity and chemical consumables, and is generally reusable, so we reduce the amount of waste. One of the other functions that we use the technology for is for emissions and odor control. So we can use that same floating layer as a reactive barrier on the surface of the water that immediately traps and then treats in place some of the conventional greenhouse gases or volatile organics that would be seen in some processed water ponds. And so this is a technology that we started at the universities of Waterloo and Toronto. It's a spinoff that is built here in Canada and was developed in support of some of our resource sector. We're really excited to be able to have the support of MICA to be able to move this technology forward. So we'll talk a little bit about how the technology works before we jump into some of its applications. So as I mentioned, there's two key functions. This advanced oxidation process, which, as I mentioned, will collect sunlight using this floating proprietary technology that we developed that incorporates the catalyst, the component that consumes the sunlight and generates treatment chemicals from the water and dissolved oxygen. As well as the other components of that material that allow it to float and be durable and able to be used across large surface areas of processed water ponds and other water bodies. Those oxidants then go and break down a variety of contaminants in the water, in some cases organics, which we'll be talking about today, but also dissolved metals and organometallic compounds. The idea here is that we take a system that can be retrofit into existing water structures or built using some very simple process infrastructure, and enables it to be able to operate in a low energy and chemical free way that greatly reduces the operations cost and operator input necessary for running these systems, which is particularly unique and interesting for resource sector applications where there is the benefit of some space and time to do treatment with the benefit of reduced cost and complexity. For the floating reactive barrier application that I talked about, it performs a similar function in terms of the actual treatment pathway, but uses the benefit of that buoyant surface coverage that spreads to cover the entirety of the water body within our containment systems. And the other thing that it can do here is actually trap and treat some gas bubbles, as well as the dissolved volatile emissions that would be coming from the water. So day and night, it's performing that blocking function to be able to reduce the emissions from the surface, but does also have the benefit that it can treat those contaminants in place and bring down their concentration over time, or manage a source term in the pond. And so the goal here is to be a GHGs and odor reducing solution where that's necessary for operating water management. So the way that the technology is deployed for us in this application is particularly useful for enhancing some of our oxidative treatment. So there is use cases where we would be deploying this. The one that's one of the focuses of this this project with MICA is treatment in Canada's oil sands. So the idea here is that we're doing treatment on mine impacted water, where we would be performing an oxidative treatment on the dissolved contaminants in the water and converting that into treated organics or other dissolved compounds downstream. So this can either be receiving it from an upstream treatment body, or potentially doing treatment prior to it entering some of these wetland systems. And so the idea here is that we can do a passive polishing of that effluent and treatment to be able to perform the given function that we're looking for. So that's high strength of oxidation, and the ability for us to improve effluent in a continuous manner there with lower input is particularly attractive. Just jump ahead here. Sorry, Charles, I'm realizing I've got, I think, potentially the wrong slide deck open here.
No, no problem at all.
So this is how SolarPass looks in operation. So we deploy the material onto the water body or in a built-for-purpose treatment system. You can see pictured on the right some of our pilot systems in operation, as well as in the bottom right a system operating in a treatment pond where we have our treatment material inside of that containment system. The idea here is that we're getting a high strength of oxidation, sunlight activated, and being passive and low input in a system that can be retrofit directly into ponds or used in a modular and mobile format. I think this is particularly interesting for applications where we're looking at remediation or projects that are a component of continuous operations, either or having a system that can be installed permanently or used in some remediation or cleanup that may be necessary across a mine operation. So I mentioned previously the deployment into oil sands mining, and this is one of the focuses of the project, which I'll talk a little bit about here. So mine water management is obviously a critical component of operations within our surface mining operations in Canada's oil sands. Treatment of some of the dissolved organics that accumulate in those waters through many cycles of reuse does require some treatment and amendment before they may be eventually returned to the watershed or handled in other mine closure plans. Currently, there's a substantial amount of water that's stored in these mine operations in the order of about 400 million cubic meters. And that water is in active mine operations reused and up to 80 to 85% of their makeup water. However, in looking forward to the return of this water to the watershed and mine closure, looking for solutions that can be used to treat that in an accelerated manner instead of relying on natural degradation processes to attenuate some of the toxicity that's related to organics in the water, as well as bring that water quality to a level that that meets the discharge criteria in development. So one of the things that we developed this for was addressing this industrial priority area for the oil sands, specifically looking at passive organics treatment. And it was one of the genesis components of developing SolarPass. And so our goal here is to accelerate the passive or semi-passive treatment of that water to be able to do so in a way that is green sustainable and reduces some of the costs of remediation. And so the way that we do that is we use these two key functions, the ability to conduct direct treatment on the water, so accelerating that reduction in toxicity, as well as the benefit of us being able to use this treatment for general organics treatment and transformation, specifically looking at things like increasing the overall biodegradability of those organics so that downstream processes can work in co-treatment with some of our our treatment process. That's actually one of the things that we're looking to study through the MICA program, and basically advancing the science and development of this treatment process. One of the other areas that we're taking a look at is treatment of selenium and organoselenium, specifically looking at where oxidation processes can be used to transform and treat some of the trace amounts of organoselenium in water, because of its ability to be that bioavailable form of selenium. There is some concern about how it might interact with some of the downstream receiving environments. And so we're looking at solar pass as a mechanism to work in concert with other treatment processes for those selenium compounds, and developing something that again would be retrofit ready or able to integrate into other existing passive selenium treatments. And so that will be another component of some of the research and development that's being done for looking at solar pass's application into the mining sector here. And then additionally, it talked about some of the treatment for emissions control and treatment. This is another venue that we're looking at applying solar pass through the project, especially as it relates to potentially things like sulfide generation in treatment of acid mine drainage and other mining applications where there are concerns about emissions and odors from ponds, and being able to use our technology to passively treat and transform those emissions over time. One of the additional applications of this floating layer is also as a manner of control of evaporation, both reducing it and increasing it. And so we can actually use this as a mechanism of brine management as well, in enabling us to further accelerate some of the evaporation and crystallization that's happening in ponds. So where there may be existing treatment processes for dissolved metals or dissolved solids removal, we could potentially use this for management of some of those brines, as well as directly in the production process for mines where evaporation and crystallization is used in solution extraction. And so speaking to that specifically, the photothermal enhancement component is another component that we're exploring with some of our early adopter partners right now, and examining whether we can utilize this technology as a direct enhancement for evaporation and crystallization ponds as a mechanism to create a photothermal enhancement of the evaporation using this unique floating technology that we have, and some of the proprietary materials designs we have incorporated into that to accelerate some of that heating and increase the heat absorption from the sunlight in those ponds. And so we've been able to show that in some initial proof of concept through this program that we have some accelerated evaporation and are working on ways of enhancing that based on some of the initial data we've received. Finally, speak to a couple points on some additional mining opportunities. We've been examining using this oxidative process for waste valorization, using oxidative treatments to precipitate or transform metals for better downstream processing, especially as a manner of extracting additional value from tailings and in that water treatment cycle, and polishing residual contaminants that may be present from either existing water management drains or as a component of treating some of that processed water in place before it leads to polishing for release. And so there's a variety of different process aids that evolve from the mining process that we can use this oxidative treatment to treat, and instead of some of the conventional oxidation methods. And finally, as I mentioned earlier, application of the Solar Pass FRB as a component of accelerating some of that treatment of hydrogen sulfide emissions in biogenic sulfide production from those processes. So generally speaking, for the MICA project and where we're looking for additional engagement as well, we've got some ongoing and really productive work with our oil sands mining partners in some of this cross-sectional testing that we're doing through MICA on treating their waters, as well as exploring some of the new sensing controls technologies that we can integrate, and are working right now on sort of a scale up for the next phase of that into 2023. We are working with a few other partners in the mining sectors, that I mentioned previously, for metals production and minerals, are interested, of course, in finding some additional partners through the MICA network that we can continue to test and examine where this technology can be adopted, with an emphasis on that commercialization acceleration, where we're really looking for some additional applications of the technology that we can leverage some of what we've learned already from the development in the oil sands and beyond. And what that process integration looks like, we've got a very well-tooled and talented team here for lab scale assessment and developing process application knowledge to understand whether this tool can be useful for a given mine application. And then proceeding then to field trials where we can examine that at a smaller scale with some of these built for purpose laboratory in the fields that we have that can basically generate some really high quality data to examine the treatment in the operating environment, then to eventual implementation at larger scale. So we have a number of different systems that we can use for that, from the mobile laboratories I mentioned to modular pilots and the eventual implementation in either constructed systems or in situ deployments of the technology for treatment. So through the different scales of implementation and study that are necessary. We'll maybe leave some of the presentation content there and proceed to some questions with you, Charles.
Awesome.
Yeah.
Thank you so much. Yeah, and please do leave this slide up for sure. I like the information here. The contact. So Zach, thank you for the presentation. Zach, one of the questions that mining operators always ask me is, around the speed of installation of a solution. Could you just comment, from the time when you sort of identify that this solution is a fit for you to help solve a challenge, what is the typical time frame from discovery to implementation of a solution that looks like the one that you're building out?
Yeah. So that is one of the benefits of us designing it towards that more modular and potentially retrofit ready application, is that for some of these mine applications, especially, there may not be the need to do a really extensive capital planning and integration into new parts of the land lease. But in terms of the initial discovery and moving forward, we generally turn around projects here on a couple months basis for us to be able to do some initial analysis and communication with the partner on what that treatment process might look like. And then from there, we have these pilot systems that are basically ready to go at any given time. And so we can get in the field and start doing some direct study on implementation, immediately after that point. Depending, of course, on the jurisdiction. If we're in Northern Alberta, we generally wait till the summer for some of that demonstration when things aren't frozen solid. But the benefit here is that we do have the ability to integrate relatively quickly with existing systems, which I think is the highlight in terms of a faster adoption cycle possible.
Gotcha. Thank you for that answer. And Zach, I want to mention also that the crossover between what you're doing in oil sands and crossover to the base metal mining or the mineral metal mining space is actually something that we're promoting within the MICA network. So that's a really positive thing. Look, the next question I have for you is, when you actually go to a mine site or a mine operation, who is it that you would like to speak to at the mining operation? Because we all know that there's many layers to the mining company's hierarchies. So can you maybe just comment on maybe which division, which department, who is it that is best fit for you to speak to when you're approaching a mining company?
Yeah, no, it's a great question. There are large organizations with a lot of different skills to bear on bringing a technology to field. Most often we're engaging with and have found the initial conversations are best with some of the environmental professionals and managers of water management and sustainability programming at these mines. I think particularly where this is an emergent technology or maybe something that's additive to the current, productive operations of that mine. That's sort of the best avenue in for us as a new technology adoption. And so looking where we can help address sort of emergent priority areas or evolution to current operations in the mine, and then eventually have that engagement with some of the members of the actual mine operations team when it gets to a maturity that we can be starting to talk about actual integration beyond the initial proof of concept and business case evaluation.
Gotcha. All right, thank you for that. And my next question, Zach, is around the idea of our industry being a show me industry, right? Show me exactly what it is that you're talking about, a solution. So if somebody sort of says, Zach, we need to see a demonstration of the technology, how would you answer that question? Where would they go to be able to see a demonstration? Maybe just comment around that and what's coming around that whole demonstration piece.
Yeah, so I would love to bring everyone to any one of the mine sites that we're at. Unfortunately, not directly feasible, but we do have the benefit of being able to have some of the technology demonstrated both at our own facilities as well as some information we can share on what we've done in the field and what those process and systems look like. However, all that to say is that I do think one of the components from that show me approach that I think stands out most to us is being able to bring pilot systems or systems that are at maybe more of a prototype scale for that use case to the field. And so that, pictured here is one of the mobile pilots that we have. We even have some that are smaller than that, ships on basically a skid-sized unit to the site. And that enables us to be able to do it right in place directly from the source and get some of that data in a way that I think is often much more powerful than something that's simulated or just at the bench scale.
Okay, awesome. Thank you for that. All right, my next question, Zach, is how will the results of this study in oil sands mining be applicable to other industry sectors?
Mm-hmm. Yeah, so the benefit here is that, as I mentioned, the technology is a broad scale oxidation technology. So we do have the ability to treat a variety of dissolved contaminants in water, or in the case of valorization, I guess productive outputs, using that system. So the scale up and development of the process design and operations that we're learning from developing this technology in the oil sands is really directly applicable to any of the other mining sectors that are dealing with process and tailings management. And so in terms of beyond just understanding the specific use case and target contaminant, which, as I mentioned, we've got some of this learned experience in piloting and demonstrating it in the field that we can now translate. The scale up of that and the maturity of technology and its operations is really broadly applicable and something that we think we can productize, for lack of a better term, from the learnings we've gotten there.
Thank you for that answer, Zach. Appreciate that. My next question for you, Zach, is what types of additional mining use cases are you targeting with SolarPass?
Mm-hmm. Yeah, so there's a variety of them that we're looking at. And as I mentioned, really particularly interested through the MICA network of expanding some of our base metals or mineral metals applications, as you mentioned. So we've been doing some exploration into areas such as copper and gold mining, as well as I mentioned some of the evaporation components, also touching on lithium and potash. So there's a number of different mining verticals that we think this can be particularly interesting in, and in ways that are maybe a bit outside of the conventional oxidative treatment box that you might otherwise think of would be mostly oriented towards oil and gas and the organics space. So and then the other one I'll mention too is on the metallurgical coal and coal power side. We talked about some of our investigation of selenium compounds, and that's been a particular focus for us recently with some positive results. And so looking for additional partners who might be interested in that space.
Okay. All right. Thank you for that. Okay. Next question, a little bit long. Mm-hmm. What are the benefits of transitioning from sort of an active treatment process to your passive treatment system? Mm-hmm. And also, how can SolarPass enhance current processes?
Yeah, so compared to active systems and translating over, one of the benefits here is that lack of active process is the mechanism in which we make it greener and more economical. So, and the other component that comes into play here is using this as a enhancement to current processes. We're not necessarily positioning it solely as a standalone technology, but particularly where we can enhance existing water treatment and management. So thinking about areas where partial treatment or transformation of these compounds, say, makes downstream biological or wetlands treatment more efficient and effective, are areas where this can be enhancing overall passive management, or in processes where it may be upstream of some active method to reduce the amount of chemical input or energy input required, or even just the system scale downstream. So uses there that conventional phys chem processes are nice. They just work whenever you turn them on, but that does come at a cost of inputs and operational hazards that we can see SolarPass as being able to allay, with the benefit of being a greener and lower cost approach. And from that, it gives us the ability to integrate and enhance some of the other processes that are used in current mine water management.
Okay, awesome. Thank you. And Zach, I do have one more question for you. I may have
Mhm.
another, but this is the one question I got for you is, how do you adapt your control of the treatment water quality to changing conditions or effluent water composition?
Mhm. Yeah, one of the questions we often get is in that realm in terms of what if the sun isn't out as much, or what if the seasons change, and what if the process conditions adjust. So though it is a passive technology, we have developed a operational process and a set of controls that allow us to accurately monitor and adjust the process flow and operation around the given environmental conditions. So if it's a sunnier day or not, being able to meter and adjust the flow rate to ensure that the water is getting the target dose. Or if we're operating in a large pond, that would be just simply an averaging over the operational period. And then with that, if we have some changing influent qualities, or frankly, even I guess effluent, if there is a change in what we want as the operational parameter, we can dial up and dial down the amount of treatment contact time and the operational conditions of the system to work within that. So we always try and make sure that we emphasize that it's passive insofar as that it's not an active chemical and energy input. But there is the benefit of us having the expertise on how to best operate and get the highest performance out of this in a field setting, which is one of the important nuances and components of making a passive photocatalytic system like this viable in an industrial setting.
Awesome. All right. You know what? I do have one last question that was just Johnson can see me. So that question is, often when we talk to mining companies, they always say, "Oh, Charles, sometimes we get to hear the pricing model too late into the conversation." So, at what point in your engagement with the company would you sort of speak about pricing?
Yeah, I mean, we can for any given application, if someone's reaching out, we can do our best to give the pen and paper assessment out of the gate. The best case for us is after an initial test at the lab scale and being able to get some of the treatment kinetics and performance out. It is important that we have an understanding for the client what the treatment requirement is and the setting it's going to be operating in, because that necessarily affects the size and scale of the system to achieve the results. But one of the reasons we've invested a lot of time and energy in developing that initial screening and assessment of a given application is to save everyone time on making sure we have a frank conversation on the applicability and business case of that technology before we get too far down the development pathway. So, yeah.
Okay, thanks, Ben. Well, Zach, again, I want to thank you for the time you've taken to really sort of explain Solar Pass to us. I can understand now, where the opportunities are. And I'm so happy to see that, that you're helping us to broaden out where innovations for mining are coming from. And I think this is going to be a trend we'll see happening in the industry moving forward. So, Zach, last time I had a webinar, I did give the presenter a chance to kind of say some parting words to the ecosystem. So, Zach, you've got about another minute to go. What is it that you want to tell the ecosystem before we say goodbye?
Yeah. No, well, thanks so much to the MICA ecosystem for all the support so far, and really grateful that there's a growing network of these mining innovations in development. The big one for us is as a growing company and one looking for additional applications of the technology. Really would like to hear from some of the stakeholders in both operations and management of these mining projects, where we can apply Solar Pass as a solution for them, and understanding where this water treatment process may be a helpful application in different niches in the industry. So any and all outreach in terms of better understanding what we're doing and what we can do for a mine operation is something that we're really looking for. So we'll happily take your treatment application and inquiry and see if we can find a way to make it a value add for you.
Awesome. Thank you very much, Zach. Looking
Okay,
forward
thanks.
to again. You take care.
Okay, thank you. Bye-bye.